Welcome to this explainer. Today, we're going to attempt something, well, massive. We're taking a cosmic journey, zooming all the way from the absolute beginning of the entire universe, the Big Bang, right down to the emergence of the human mind on our one little rocky planet. It's kind of the ultimate origin story, pieced together from some of the most incredible scientific discoveries we have.
Okay, let's dive into this roadmap. To make sense of a 13.8 billion year journey, we've broken it down into 5 distinct stages: the cosmic beginning, birth of the solar system, forging planet Earth, the puzzle of life, and finally, understanding our origins.
13.8 billion. I mean, just let the sheer scale of that number sink in for a second. Before this exact point, there was no time, no space, no matter as we know it. But 13.8 billion years ago, the whole shebang kicked off.
Section 1. The cosmic beginning, from singularity to transparency.
Okay, so starting with that ultimate singularity, the early universe's timeline is really just a story of extremes. In literally a fraction of a second, an era we call cosmic inflation expanded the universe faster than the speed of light. And then within just 3 minutes, the universe was this primordial soup sitting at an incomprehensible 10 billion degrees Celsius. That's where the very first elements, like hydrogen and helium, were actually forged, but it was still incredibly dense. It took roughly 380,000 years for the universe to cool down enough for atomic nuclei to finally capture electrons. This epoch is called recombination, and it's what finally allowed the cosmic fog to clear, making the universe transparent. Fast forward to about a billion years, and the first stars and galaxies had ionized the gas, giving us the universe we actually see today. Now, when that cosmic fog finally cleared at that 380,000 year mark, light was finally free to travel. And the crazy thing? We can still see it right now. We call it the cosmic microwave background, or CMB. It's the literal leftover radiation, like a glowing afterglow, from the universe's fiery birth. It is absolutely the oldest light we can possibly observe. And the way we discovered this profound truth is, well, it's pretty hilarious. Back in 1965, 2 scientists, Arno Penzias and Robert Wilson, were picking up these strange, higher-than-expected temperatures on their radio receiver. Now, they didn't immediately think, aha, the origins of the universe. No, they actually thought the anomaly was caused by pigeons roosting and leaving droppings inside their giant antenna. They scrubbed it all out, but the signal was still there. They had completely accidentally stumbled upon the literal echoes of the Big Bang. Section 2. Birth of the solar system, from dust to planets. All right, let's do our first major zoom in, shrinking our focus from the vast cosmos down to our specific neighborhood. So fast forward about 9 billion years from the Big Bang. We're now 4.6 billion years in the past. In our little corner of space, there was no sun, no Earth, just deep, dark, empty space containing a massive cloud of dust and gas called a solar nebula. And this brilliantly illustrates how a chain reaction brought our local neighborhood into existence. It started with a bang, not the Big Bang, but a nearby supernova explosion. The shock wave from that dying star slammed into our peaceful dust cloud, causing gravitational instability. So the gas and dust start to compress and spin, flattening out into a rotating protoplanetary disk. As the very center of this disk became impossibly dense and hot, nuclear fusion ignited. Hydrogen started fusing into helium, and boom, our sun was born. But here's the thing, when the sun ignited, it consumed almost everything. The sun makes up a staggering 99.8% of the total mass in our entire solar system. Think about that. The Earth, giant Jupiter, Mars, every single moon, comet, and asteroid you've ever heard of, all of it was built from that tiny leftover 0.2% of debris. We are quite literally living on cosmic scraps. So how exactly do cosmic scraps become planets? It happens through an absolutely crucial process called accretion. In that spinning disk of leftover dust, tiny particles just started bumping into each other. Because of static electricity and chemical bonding, they stuck together. Over millions of years, millimeter-sized specks collided to become rocks. Rocks became boulders, and boulders gravitationally pulled together to form planissimals. Section 3. Forging planet Earth. A ball of boiling lava. Let's zoom in once again, right down to the Hadean Eon. Early Earth was absolutely nothing like the blue marble we live on today. It was basically a massive ball of boiling lava, just constantly getting bombarded by asteroids. But as it slowly started to cool, this massive sorting process happened, totally driven by gravity. Just like how heavy things sink in a pool of water, the heaviest elements, like iron and nickel, sink deep down to form the Earth's core. The lighter elements, like oxygen and silicon, floated up, eventually cooling to form the Earth's crust. And of course, that crust isn't one solid piece. It's broken into tectonic plates that have shifted over billions of years, creating supercontinents like Pangaea. Now, what's really interesting about this is how we got our moon. It wasn't just some random rock that got caught in our gravity. Scientists now widely believe in the giant impact hypothesis. Around 4.5 billion years ago, while Earth was still this molten ball, another Mars-sized protoplanet named Theia smashed directly into us. It's wild to think about, but the cores of the two planets actually fused together, while a massive chunk of debris got blasted out into orbit. And that debris eventually coalesced into our moon. It sounds incredibly violent, right? But here's why this matters. Without this horrific collision, you and I wouldn't be here. The moon gave us some vital gifts for life. That massive crash knocked Earth onto a 23.5-degree tilt, and that tilt is what gives us our stable, predictable seasons. Plus, the newly formed moon generated oceanic tides, which a lot of scientists believe were absolutely crucial for helping early living organisms eventually make the evolutionary leap from the water onto the land. Section 4. The Puzzle of Life, Probability and Perspectives. And that brings us perfectly to our next zoom in, the microscopic scale. How on earth did inert matter suddenly become living matter? You've probably heard this famous analogy from the late Stephen Hawking. He used the idea of a horde of monkeys randomly hitting typewriters to explain how complex order could, eventually, arise by pure chance. Given a long enough timeline, random, chaotic actions might just produce a Shakespearean sonnet. But when we apply the actual real-world math of molecular biology to this analogy, the numbers get pretty staggering. Let's look at the mathematical odds of forming just a single functional protein by pure chance. Proteins are the building blocks of life, and they're built from specific sequences of 20 different amino acids. If you take a relatively short protein, say just 200 amino acids long, the number of possible combinations is 10 to the power of 260. That is a 1 followed by 260 zeros. To put that into perspective, if every single drop of water on Earth held a mutating cell and it divided every single second for the entire 4 billion year history of our oceans, you'd only get about 10 to the power of 50 total mutations. The vast biological space of failing options is unfathomably larger than the amount of time our planet has even existed. Because of this extreme mathematical improbability, the source material highlights two very different perspectives on life's origin. On one side, you have the neo-Darwinian or materialist perspective. This view posits that life developed entirely via unguided random mutations and natural selection, working over vast eons of time to eventually climb that mountain of biological complexity. On the flip side is the teleological or directed perspective. This view argues that the extreme statistical improbability of random chance producing a functioning protein actually points to a foundational wisdom or a design embedded into the very fabric of the universe right from the moment of the Big Bang.
Section 5. Understanding our origins. Looking back. So let's do one final zoom out to see how we, sitting here today, relate to this massive timeline. What's so fascinating is how deeply this epic cosmological history permeates our everyday lives. Scientifically, we are literally building time machines. Things like the James Webb Space Telescope are out there peering billions of years into the past, looking at the very first galaxies. And culturally, well, the Big Bang Theory became a household name through a massive 12-season sitcom. They actually used real astrophysicist consultants to make sure the equations on the whiteboards in the background were totally accurate. We are a species just obsessed with understanding where we came from. Which leaves us with this really beautiful final thought drawn from our sources. Every single atom in your body, every piece of matter on Earth, it's all built from the condensed light and energy of the Big Bang. You aren't just in the universe, you are quite literally made of it. So as you sit here today, using your conscious mind to learn about the origins of the cosmos, are you simply the universe, after 13.8 billion years, finally waking up and beginning to understand itself? Think about that for a while. Thanks so much for joining me on this explainer.